Suppose that we have an angle here, which is this one, and this here is the extension of this ray on the other side, so this here is a line. And suppose that we draw this red line through this point, such that this angle here equals this angle here. So, for example, this is a 25-degree angle, and this is a 25-degree angle. Then we call this red line the angle bisector of this angle, because it essentially bisects the angle. If the whole angle was 50 degrees, then the two small angles are 25 degrees each. And now let's construct this purple line such that this angle equals this angle. Then the purple line would be the angle bisector of this angle here. Also, with respect to this angle, this line is called the external angle bisector of this angle, because it bisects the complementary angle of this one, which is this one, the angle that complements it to 180 degrees. So we're going to call the red line the internal angle bisector of this angle, and the purple line the external angle bisector of this angle. Now let's try to find this angle. We know that the whole angle is 180 degrees, and this angle is 50 degrees. Therefore, this angle must be 180 minus 50, which is 130 degrees. And this angle equals this angle. Therefore, each of those angles is half of 130 degrees, or 65 degrees. Note that the angle between the red line and the purple line is 90 degrees, because 65 plus 25 equals 90. And so we have a right angle here. It turns out that this is not a coincidence. See, if this angle is x and this angle is x, then this angle is 180 minus 2x, because the sum of 2x and this angle must be 180 degrees. And therefore, this angle is 180 minus 2x, so this angle must equal the half of that, which is 90 minus x. And now the sum of x and 90 minus x is always 90 degrees. So the internal and the external angle bisectors of an angle are always perpendicular to one another, meaning that the angle between them is 90 degrees. Suppose that we have two lines that intersect, and we know that this angle is x. Let's try to find the other three angles on the picture. We know that when we have a straight line, this here is 180 degrees, and therefore if this is x, then this is 180 minus x. Similarly, here we have a straight line, so this angle is 180 degrees, the straight angle. And so if this is x, then this must be 180 minus x. And now we have a straight line here, and so this angle is 180 degrees, and we know that this angle is 180 minus x, therefore this angle must be x. So we got that this angle equals this angle, and that this angle equals this angle. Now suppose that we have a line, and we have 3 points, a point A here, a point B that lies on the line, and a point C here. And we need to show that A, B, and C lie on a straight line. What do we do? Well, we can just prove that this angle equals this angle, and then it will be done. So suppose that we proved that this angle equals this angle. Then we can use the fact that this is a straight line and show that this angle is 180 minus x, because we know that this angle is 180 degrees, and this angle is x, so when we subtract them, we get that this angle is 180 minus x. And hence, the sum of this angle and this angle is 180 degrees. Therefore, this angle here is 180 degrees, angle A, B, C, and therefore A, B, and C must lie on a straight line, since 180 is the straight angle. This is a technique that we're going to use a lot throughout the course. Now let's return back to this picture where we have an angle that measures 2x, and we draw the angle bisector of this angle in red, so this angle equals x, and we draw the external angle bisector of this angle, so this angle equals 90 minus x, and the angle between the internal and the external angle bisector is 90 degrees. Now let's fill in the missing angles in the picture. We know that this angle is x, therefore this angle is x. We know that this angle is x, therefore this angle is x. We know that this angle is 90 minus x, therefore this angle is 90 minus x, and we know that this angle is 90 minus x, therefore this angle is 90 minus x. This is the optional problem. We're given an angle that measures gamma, and we need to construct the angle 90 minus gamma over 2. What we have is a magic ruler. The magic ruler is such that it can bisect any acute angle. So for example, you can tell the magic ruler, bisect this angle gamma since it's acute, and it will draw the angle bisector here, making an angle gamma over 2 and gamma over 2. So our goal is to get the angle 90 minus gamma over 2 by using the magic ruler. And here's the solution. First thing we need to do is we need to continue this line like this, and then we need to draw a random line that also passes through this point, and is such that this angle is acute and this angle is acute. Such angle exists because of the following reason. this angle is gamma, so this angle is 180 minus gamma. And 180 minus gamma is smaller than 90 plus 90. And so we can have two angles that are smaller than 90 degrees, and such that their sum is 180 minus gamma. And so we can use this line to divide the angle 180 minus gamma into two angles that are smaller than 90 degrees. And now we can use the magic ruler to bisect this angle and to bisect this angle, because these are acute angles. And then we get this angle equals this angle, and this angle equals this angle. Let's call this angle x and this angle x. Then this angle must be 180 degrees minus gamma minus x. So 180 minus gamma minus 2x. And therefore, each of these two angles is half of this. So 90 minus gamma over 2 minus x. And now take a look at this. This angle measures 90 minus gamma over 2 minus x plus x, which equals 90 minus gamma over 2. So the angle between the two red lines is our desired angle, 90 minus gamma over 2.